Здрасте всем, меня зовут Егор. Хотел сказать большое спасибо организаторам за то, что нас так много сегодня здесь. И за то, что они согласились меня послушать сегодня. Спасибо вам, что пришли. So, I'm gonna speak in English and I hope we will understand. And if you have any questions later, you're free to ask in Russian as well. I'll translate to English. In the next 30 minutes, I'll try to explain you why continuous integration as a technology, I believe, is not working anymore, and what I think is an alternative or how we can improve this situation. And then I will answer your questions for another 20 minutes or so. A little bit of a background of myself. I live in Silicon Valley, close to San Francisco. I'm a CTO and co-founder of a small software development team. And my background in continuous integration lasts for probably maybe 6 years or 7 years. We started to use Continuum, Apache Continuum a long time ago. Then we switched to Cruise Control, then Hudson, then Jenkins, then Travis. And about half a year ago, we started to use AppWare. So all these solutions are continuous integration services or servers. And I'm just showing them to you to explain that I know how they work, and I still think that they don't work in reality. So they don't really help software developers. And here is why. So let's start from a simple example. We have a team of developers, more than 2 people, 2, 3 or more. And they work the first step to actually make our work more disciplined, more organized. We start to work in branches. So one developer is working on one thing, one ticket, one problem, another one, another problem. And then we put this stuff into master branch. I think that most of you use Git right now, but it doesn't really matter. You can use any other version control system like Subversion or whatever. But the point is that we develop in parallel, and then we put this stuff into one main storage of code, which is called master branch. And Git helps us to resolve, conflicts and to make sure we actually work at the same time with the same file in parallel, and we don't have mess, we don't have chaos, we have more or less organized work. And this is the first step. This is how it was before continuous integration. And then the idea of continuous integration, eventually we get from master branch and we put this stuff into production. Somehow we package, we deploy, we probably do some DevOps operations on this step, and we put the stuff into production. And continuous integration is, the idea of continuous integration is that we sometimes, or not sometimes, but every time we put something into master, we have a continuous integration server which actually gets this stuff from master, tries to test everything, and gives us a green or red light. Is it a good code? Is it still a good code after the stuff which I put after my friend? So I did some changes, I put these changes into master branch, and then the continuous integration server says, you know what, you just broke the build. So I can't test it anymore. I can't, package all this software together. It just doesn't work anymore. That's the idea of continuous integration. That's how it sounds. Or the build is still clean. Like I did some changes, I modified some code. The build server says it's still clean. It's still in the same stage, in the same state as it was before. That's continuous integration. And this is where the problem comes from. There's a famous book about continuous delivery by Jez Humble. And the book says that if the build fails, I just quote the book, the development team has to stop developing something else and fix the build. So if the continuous integration service says the build is broken, the code can't be tested anymore, the code doesn't work anymore, we all together have to stop and immediately resolve the problem to put the build back to the state where it's green. That's the point of continuous integration. And this is what doesn't work. In my experience and in all the projects we're doing. Why it doesn't work? Mostly because the main question is who needs this? Who needs this? Who needs us, all of us, all the developers, for example, like 10 people in the team, who needs us to stop and do something else instead of continuing developing? So imagine 10 people developing something and then one of us just broke the build. So according to the book, 10 of us have to stop and because we can't work anymore because the build is broken. because the software is not stable anymore. So we have to stop doing what we're doing right now and get back and fix the build. And the main thing is that who benefits from this? Who actually needs this? The CTO of the company? Not really, because the CTO wants us to develop new features. So he doesn't want us, or she or he doesn't want us to stop doing what we're doing. The architect? Not really. The architect, again, is interested and motivated to develop new stuff, not to fix some red light on some continuous integration server. Product owner. Product owner needs new features. He needs the sprint to finish. He needs the sprint to include all the features which we plan to include. So we don't want. So the point is that nobody needs us to stop. Nobody wants us to stop. And if somebody in the team will say, "Hey, the build is broken. We have to stop working what we're doing. We need to fix the build," everybody will be against this person. Everybody will say, "No, we have our own plans." So what happens in reality is this. This is a snapshot of Travis, the continuous integration service I'm using. And you see one build is green, one build is red. One build is green, another one is green, another one is red. So it's a mixed situation. Sometimes the build is clean, sometimes the build is red. Which means, in reality, that we don't pay attention to this anymore. We just don't care. Is it green? Is it red? It's just a signal for us, which doesn't mean anything anymore. So the continuous integration is just a nice feature which we paid for, which we spent some time for, and then we don't care about it anymore. It's just green light, green light, green light, green red, sorry, green red, green red. That's it. So this is what we have. This is what we had before we started to use what I'm going to explain now. So this is what I see in many projects, which we do consulting for, which we do software development for. We just see this situation everywhere. And people asking us, like, why do we pay for this continuous integration? What does it give for us? What do we need this red, green signals for? And sometimes the answer is, so what about the discipline? Like, how about I expect this kind of question from some of you. I expected that. So this is a typical question saying like, hey, there's a discipline in the team. So people have to be more disciplined. They shouldn't break the build. They should not put some broken stuff into master. They have to be more disciplined. And this is what discipline leads for. If you, in some teams I know, for example, in Microsoft, it's a famous story. They say that if somebody breaks the build, they give some kind of a hat to this person, which he has to wear for the next day or something. So they kind of put a blame on this person. They just say, you broke the build, you broke master. So now it's like you have this funny hat on your head for the rest of the day. And this is, I call it blame. So we blame this person and we say, you broke the build, you're the guilty one, this is some punishment for you. What this blame leads for? The blame leads to fear. If I know that I'll be blamed for that, I don't want to break master branch. So I'm afraid to do this. I'm afraid to touch the master because I know that everybody will blame me for that. And this fear leads to longer branches. It means that I will work on my stuff for a long time until I'm 100% sure that it's perfect, that it's not going to break master. So I'm not going to put some stuff which I work for half an hour and then I put it to master. I will work for a day, or maybe 2 days, or maybe even longer, until I'm perfectly sure that this stuff is safe. And long branches, they lead to throwaway branches, which mean branches which I throw away eventually. So I spend some time on them, and then when they're getting too long, I just throw them away, because I can't put them into master anymore, because they are too old and stuff is already gone away, far away. So I just throw them away, which means losses. I mean, money and time. So we pay for the developer to work for a few days on something, and then we throw it away. So in this case, my point is that, in this case, the discipline makes only bad things, not good things. So if you enforce people to keep the master branch clean, in the end, you're going to have losses of time and money. because they are afraid to break the master. So what's the solution? I try to explain the problem now. Here's the solution, which I think is the solution. So as you see, the continuous integration as it is, it's just not helping us. It's just giving us signals red and green, and we don't pay attention to them. And if we start to pay attention to them, we have like problems in long branches. So what's the solution? Here it is. The idea is that the master branch, which this idea is not like, it's not mine. This idea, I got it from the market, and some companies use it, and it's called, some people call it, pre-flight builds. So the idea is that when I have a branch and I have some code, I can't put it myself to master. I just technically can't touch master branch. I can't push it there. I can't do git push a region master. This is not what I can do. I don't have permissions for that. So I put a merger, a tool, a DevOps tool, a server, a build machine, which gets my stuff from the pull request or from my branch, and then merges it into master, and then runs the full integration and everything, all the tests at this stage, at this point, before putting the stuff into master. So we don't run we don't run continuous integration after everything happened, after we touch the master, but before we put the stuff into master. So the merger is the machine which gets my stuff, gets master, puts it together, resolves conflicts. Not resolves conflicts, but if there are conflicts, there's a rejection. But if there's no conflicts, it runs the full test, integration test, unit test, whatever, and then pushes to master. So there is only one person, one user who can push stuff into master. It's this merger. So no human being, no person, nobody can put stuff into master. That's how we protect master. And it's called pre-flight builds. So pre-flight builds, that's the name I found on the internet. So the idea is to have this merger. So that's how we solve the problem. And I created a tool which is called rulter.com. And it works on GitHub, so on GitHub only right now. So the idea is that in our projects, we work on GitHub mostly. So in our projects, we make the master branch read-only. So nobody can touch master branch anymore. We have teams sometimes of 25 developers, and none of these 25 developers can touch master branch. We work only through pull requests. So every time you want to change something in the code, you create a pull request. You create your fork in GitHub, then you create your branch on GitHub, and then you create a pull request with your changes. And then, right inside pull request, we just say, could you please merge it to the tool? It's a chat bot. It's a bot which talks to you in GitHub. And it starts all this. It starts a Docker container. Inside this Docker container, it builds everything. It tries to merge first, then it builds everything, and then it pushes to master. That's how it works, technically. So again, this rulter is the merger on this picture. So it's somebody who stays between me, the developer, and the master branch, the main code base. So it protects my master branch against myself. Because I'm, as a developer, or my friend, or any other developer in the team, is basically the potential threat to the master branch. And if I break the master branch, we know what happens. We have this problem, we have fear, blah, blah, blah. So we don't want to break master branch. We don't want this red signal from this server. And having this merger, we have mostly the green signal from continuous integration server. Mostly green. That's what happened in this case, because we reject a lot of broken things on this pre-flight build stage. Because when some developer is creating something which potentially causes a broken unit test, or a merge conflict, or a static analysis problem, then we just reject it on this stage. We just don't let it go through. It doesn't go to master branch. And the continuous integration is not going to give us the red signal, almost ever. And this is the tool. You can try it yourself. It's free, it's open source, it's hosted, and it's open source as well. So you can see the code of even the code of this tool. So it's quite simple. So here's my last slide. So what do we give after all of this? First of all, 95% of builds are green. So we don't see this picture anymore, green, red, green, red. We have mostly green. And if it's red, it means that something is wrong inside our unit testing or integration testing setup. It means that the tests are not stable. If the merger actually got the code, tested everything, put the stuff into master branch, and then the continuous integration says, boom, it's broken. It's really rare situation. It happens like not very often, 5% of cases. We have no fear of breaking master. So developers are not afraid, like in this Microsoft example, which is ridiculously wrong, I believe. So Microsoft is wrong in putting the blame to developers. In our case, there is no blame, no fear. So any developer is welcome to break master. So try it. Create the code which is potentially dangerous. We're not going to let it in because we have this merger which will reject your code. So don't be afraid to make changes to the code. Just put whatever you want there, be free, nobody going to blame you. So the point number 3, no blame, which means that if you broke something, it's not your fault, it's our fault. Because we didn't manage to configure our unit testing framework to protect us, I mean the master branch, against you, if you manage to break something. So we don't blame developers for breaking master branch. We blame ourselves. We blame people who configured this Docker container which tests everything, and etc. So the developer has no blame, which means no stress, which means you can create multiple branches a day, you can push them, you can freely work actually. You don't really care about this blame, the guilt. And number 4, we have quick and small branches. It means that changes can be put into master into small branches. Developers don't wait for too long. They just create whatever they want, a few changes in a few files, put it into master. If there's a rejection, if it's not going to work, you're going to get it back. So you're not going to break, you don't need to sit on one branch for a long time, waiting until it's perfectly clean. You just put your stuff in there freely, without any problems. So that's what we have. So continuous integration by itself, that's my point again, continuous integration by itself, it doesn't work. It's just a signal which nobody really cares about. If you want to make it work, you need to put a new component in front of continuous integration server. And that component is called the merger or whatever. That's it. That's my blog, that's my Twitter.